Hi there. We are sourced, and this is Evidentia. Evidentia is a grounded output explorer, which it sounds complicated, but what it basically means is that when you prompt an LLM and it uses an agent, how do we know what the output of the LLM is corresponding to the actual tool use? What if the agent is just hallucinating something without actually using the tool itself? Uh, this confidence gap is the problem that we are trying to solve. Uh, how we do this is that we create knowledge graphs out of the inputs, knowledge graphs out of the outputs, and knowledge graphs out of the evidences, the sources that the output has used. We do this by using the value search API to get the evidences. I'll show you a quick demo, a quick example of this. So I have asked here the LLM what is the capital of the US. Very simple question. It gives an output saying the capital is this and some more information about DC. And this is the graph that's created by Evidentia. Now, in this graph, we see that we have three layers. This is the input layer, this is the evidence layer, and this is the output layer. uh, each out the output is chunked, and so the first chunk would be something like the capital is the Washington DC. The second output is one subpart of how what DC is, basically how it came to the answer. And it also has links to all the evidences that we have used. So the value search API would have used some of these evidences, and we have connected these evidences to the exact output, the exact chunks of the output that are generated by these evidence. So for example, this output is generated by this evidence with a confidence score of 0.51. So using this, the user will have a lot more confidence that their output is grounded in some evidence. And if the output is not grounded in an evidence, so we might have an output node here which is not grounded in any evidence, we can classify it as something that's hallucinated. Or if the evidence is really weak, so it will also help us identify hallucinations, things in the output that are not derived from any evidence. So yeah, thank you for listening.
I'm quickly going to demonstrate how, by using our app, we can reduce token usage by looking at the correlated sources and picking one source out of the correlated sources. Just a bit of motivation. Let me go ahead and run the app very quickly for you. So I'm running the app right now. It's built on Streamlit. And I can ask it a question such as, what is the capital of UK? Right. And so when I ask it the capital of UK, it calls the value API and gives me all of the sources with the relevancy score. And then what we essentially do, like Akshay mentioned, we look at all the sources and we look at the correlated sources. So for instance, here we can see that source 5, 8, and 7 are correlated. So they contain similar information. What we can then do is we can then just pick one source at random from this cluster, and we can pick one source at random from this cluster, and use that to answer the question, feed that to the LLM. And below we see that when we use all of the sources, the token usage is approximately 3,000 tokens. And when we go ahead and um, prune the sources so that we remove redundant information, the token usage goes down to 4,000 tokens. So essentially, we are not losing any information, we are just removing the redundant sources. And that helps us to get a grip on the total number of tokens, and it helps us to control our energy usage. That's all for now. Thank you so much. Thanks.